Today's lesson we're going to be talking about polygons and their angles. A polygon is basically a shape that has 3 or more sides. Poly means many, gon we're going to say means side. So think of a triangle has 3 sides, a rectangle or a square has 4, a pentagon has 5, a hexagon has 6. So we have all these different shapes that have different number of sides. When we draw a polygon, we begin by drawing the sides, and when we're looking at the angles of the polygon, each side corresponds to a line that then has an interior and an exterior angle. So I'm going to try my hand at drawing this here. I'm going to try to draw a pentagon with approximately the same sides. I know it's not going to be perfect, but that's all right. We're going to assume that all of these sides are the same. So I have an enclosed shape. It has 5 sides. We call this a pentagon. And when I am looking at the interior versus exterior angles, hopefully the interior is easy to see. Interior means inside. So the interior of the angle or of the polygon is right there. Because all the sides are the same, that means this and this and this and this all have the same size angle. And we're going to call it angle A for now. So A here represents the interior angle. We also have an exterior angle, and one of the common mistakes is thinking that the exterior angle is the total outside angle, but that's not right. We don't want that. An exterior angle is the angle on the outside, but it's corresponding to a single line. So what I'm going to do is I'm going to take a highlighter, hopefully it'll be easy to see. I'm going to highlight one of the lengths of my polygon. And because of this extension, this is where I'm going to see my exterior angle. My exterior angle is the outside of one of the sides. I'm going to call this angle B. And so for each side of the polygon, it extends to its own line. So again, if I grab a highlighter here, the other exterior angle is over here. So angle B is the outside or the exterior angle of my polygon. And what you will also notice is that because the exterior and interior angles are matched up, that together they're going to make 180 degrees because they lie along a straight line. So if you're ever confused about a question, take a look at your exterior and interior angles and put them together. If the number is greater than 180 degrees, then you've done something wrong. Together, they should be 180 degrees. One of the other things that we're going to talk about is numbering your polygon. In this case, I've already said that I have 5 sides here. We're going to use the letter N to represent the number of sides in a polygon. In this case, I have 5 sides, so my N would be equal to 5 here. So again, N is representing the number of sides of a polygon. Sometimes you'll be able to know the number of sides by the name. For example, here, pentagon means 5. Triangle, right, that tri means 3 sides. Sometimes you won't know the number of sides and you'll need to be able to figure it out. So that's what we're going to talk about today. We're also going to talk about 2 different categories of polygons. We have the regular versus irregular. And the easiest way to understand the difference is that a regular polygon means that all sides are the same. So an example of a regular polygon is the one that I just drew, the pentagon there. All sides are the same length. You could also have a square, right, that all sides are the same length, a triangle where all sides are the same length. So whenever we're talking about a regular polygon, we are saying that all sides are the same. When we have an irregular polygon, it means the opposite, This means different sides. And it doesn't have to be a weird looking shape. It just needs to have sides that are not exactly the same. For example, a rectangle. It has 2 short sides and 2 long sides. This would be an example of an irregular polygon. We could also have a weird shape that looks like this. That would also be considered an irregular polygon. So regular means all of them are the same. Irregular means that the sides are different. Even if it's just one side, it doesn't matter. If they're not all the same, it's an irregular polygon. The next category is convex versus concave. Convex means that something is bulging out. Concave means something is caving in. So when you're looking at a convex polygon, you are seeing that all sides are pointing out. So it doesn't matter if your shape has 4 sides or if it has 8 sides or 10 sides, as long as all of your corners are pointing toward the outside, and again, it doesn't even have to be regular. As long as all the corners are pointing towards the outside, that means you have a convex polygon. When we have a concave polygon, what we're looking at is a shape that has a dent inside of it. So think if I were to draw an octagon here, but 2 of the sides go in like that. Because I have an inside dent, it's caved in, this is what we would call a concave polygon. And it can be in various different shapes. It could possibly even have 2 parts of it that are caved in. Something like that would also be considered a concave polygon. So convex is when the corners are pointing out. Concave is when you have 1 or more corners that have been concaved in. In this next section, we're going to talk about how to find the different angles of different sides of polygons. So here it says for a polygon with n sides, we can find the sum of its interior angles using a formula that looks like this. The sum of interior angles, and I'm just going to abbreviate this to INT and use the angle symbols of a polygon, is equal to 180 times n minus 2. And again, remember that this word sum means the total degrees on the inside. So this is all of the inside angles added up together. And also remember that this letter N represents the number of sides in a polygon. And on the next slide, we're going to do a couple of examples where we're looking at either finding the sides or finding the sum of angles. So in our first example, it says, what is the sum of interior angles in a pentagon? So when we look at this word pentagon, this prefix pent means that the polygon that we're talking about has 5 sides. So that also means in our equation, our letter N is equal to 5 because there are 5 sides. So I start with the original equation. The sum of interior angles is 180 degrees times n minus 2. And I substitute the number that I know. 180 degrees times 5 minus 2, and of course we're going to follow BEDMAS and do the brackets first. 5 minus 2 is 3, so this is 180 degrees times 3, which gives us the final answer of 540 degrees. So if we look at a regular pentagon and add up all the interior angles, our final answer is 540 degrees. In example 2, we're going to be using the same formula, but now we're going to be working backwards. It is telling us that the sum of a polygon's interior angles is 900 degrees. So how many sides does it have? So in this case, we don't know what n is. But again, we begin with our original equation. The sum of interior angles is 180 degrees times n minus 2. Now, we don't know n, but we do know the 900 degrees is the sum of the interior angles. So I'm going to substitute that 900 on this side of the equation. And what I'm going to need to do is go backwards or solve backwards to get the n by itself. The first thing I do is get rid of the 180 by dividing. And the reason I'm dividing by 180 is because on the right side of the equation, 180 is multiplying the brackets that has the n inside. So to get rid of it, I go backwards and divide by 180 degrees to get rid of it. So 180 divided by 180 is 1, so it basically goes away, and we're left with n minus 2 on the right side of the equation. On the left side, using a calculator, 900 divided by 180 is 5. And again, my last step here is to get the n by itself. I have to move that 2. And right now I have n minus 2, so to get rid of it, I'm going to add 2 to both sides. And this tells me that my final answer is a polygon with 7 sides. Now we will focus on how to find each individual interior angle. And again, we begin with our sum of the interior angles is 180 degrees times n minus 2, where n is the number of sides. Well, if this represents all of the angles, then in order to find each of the angles, I take my total and I have to divide it by the number of sides that are actually present in my polygon. So we get this new equation where each interior angle is all of our angles divided by the number of sides. So this equation represents all of our angles, and we are now dividing by how many sides we have, and that will give us each one individually. Using our new equation for individual angles, we'll now do 2 more examples. So example 3 says, what is the interior angle of a regular octagon? So here octo tells you that it has 8 sides, right? Octagon is 8-sided figure. So what is the interior angle of a regular octagon? I begin with my formula. Each interior angle is 180 degrees times n minus 2 divided by n. And here again, I'm going to follow BEDMAS. I'm going to substitute 8 for the number n, and I get something that looks like this. 8 minus 2 in brackets over 8 on the bottom. All right, and throwing that into my calculator here, I'll get 180 times 6 over 8. And my final answer is that each angle is 135 degrees. My next example, as before, is figuring out how to work backwards. So now I know that each of my angles is 128 degrees, 0.57. I begin with 180 n minus 2 over n. This is my original equation. My goal is to get the n by itself. The problem though now is that n is in 2 different spots in my equation. So what I'm going to do is I'm going to multiply both sides by n. And the reason I'm going to do that is because it will get rid of the fraction on the right side of the equation. And what it's gonna look like is this: 128.57 n equals 180 n minus 2. And then my next thing will be to distribute the brackets on the right side. Multiply that through. When I multiply this, nothing changes on the left side. So I still have 128.57 n. On the right side, I get 180 n minus 360. Now I have n's on both sides of my equation. I want them together on the same side so that I can get the n by itself. So what I'll do is I'll take this 180, I'm going to subtract it from both sides so that they are on the same side together. And using a calculator, this is going to give me negative 51.43 n equals negative 360. The last step to get my n by itself is to divide out that negative 51 from both sides. And what that's going to do, going into my calculator, that gives me an n by itself. And based on my calculator, it says the answer is 6.99980 ... And you'll notice that in the question it says about 128.57. And so when I'm going to write the final answer for this, I have to make logical sense of that. I can't have a polygon with 6.9 sides. It's either some sides or no sides. And so the wording in this question, this about here, tells me that I need to round off my answer. So 6.9, that means that this shape has 7 sides. When working with exterior angles, the following equations are used. For regular polygons, the sum of exterior angles actually always adds up to the same number, which is 360 degrees. So if you have a regular polygon, no matter how many sides it has, the answer is always the same. The sum of all exterior angles is always 360 degrees. This also kind of leads to the next one, where if you wanted to know each exterior angle, then you divide your sum by how many you have. And so to find one exterior angle, you take your 360 degrees and you divide by how many sides you have. In this example, we have a polygon whose one interior angle we know is 140 degrees, and it's a two-part question. Part A is asking how many sides does it have? Part B is asking what's the exterior angle. So because we only know one of the interior sides, I have to begin by writing my equation for the interior sides. The interior angles of a polygon is 180 degrees times n minus 2 all over n. In this case, I know that my interior angle is 140 degrees. On this side, on the other, I have 180 times n minus 2 all over n. I multiply n on both sides to get 140n equals 180n times n minus 2. I distribute my 180 degrees to get 140n equals 180n minus 360. And to continue, I'm just going to move up here a little bit. I'm going to minus 180n from both sides, and I'll end up with negative 40n on one side, negative 360 on the other. So to get the n by itself, I take my negative 360, divide by negative 40. My final answer is that this polygon has 9 sides. Now for part B, there's two ways that you can do this question. If you look back to slide number 1, you'll notice that the exterior and interior angle of any polygon lie on a straight line. So whatever your interior angle is, the exterior has to be whatever is left up to 180 degrees. Or what you could do is you could also use the exterior angle equation. So the exterior angle equation is to take 360 and divide it by the number of sides, in this case 360 divided by 9, and your exterior angle will be 40 degrees. Alternatively, you should also know, again from slide number 1, that the interior angle plus the exterior angle lie on a straight line, so that should give you 180 degrees. If your interior angle is 140, what should your exterior be so that you get 180 degrees? If you minus 140 from both sides, again, you're going to end up with 40 degrees as your answer. So to sum up this lesson, we've been talking about polygons and how to find their angles. So this is a bit of a summary page of everything we've done so far. So the sum of all the interior angles of a polygon is found using the formula 180 degrees and minus 2, where n represents the number of sides. To find each individual angle, you take the sum of all the interior angles and you divide by the number of sides that you have. The sum of all exterior angles is always the same. It is 360 degrees. To find each individual exterior angle, you can take your 360 degrees and divide by the number of sides that you have. And because the interior and exterior angles lie on a straight line, the sum of one interior angle and one exterior angle will always be 180 degrees to make a straight line. Now, the last two we didn't talk about in this lesson, but these are things that have come up in the past. Just two things to remember: that when we're looking at a triangle, that all the degrees of a triangle, no matter what the shape of the triangle is, will always add up to 180 degrees. That'll come up in some of your homework questions, as well as some of our future homework questions as well. And the degrees of a full rotation is where you start at a point and you go all the way around, essentially creating a circle. So the degrees all the way around will also be 360 degrees. So now we have done the polygon lesson. It is time for you to open up your booklets and try the questions that involve the polygons.